Similar triangles are going to be different than congruent triangles in that they are similar, meaning they have all corresponding angles congruent, and all of their corresponding sides are proportionate. That means that you can set up ratios of their side lengths, and they are equal. The ratios are equal to each other. Angle measures determine the shape of a polygon, or in this case, a triangle. So if their angles are congruent, their corresponding angles are congruent, then the triangles are going to have the same shape. They may not necessarily have the same size though. There are three ways to prove that triangles are similar without knowing all of their sides or angles. The first way is called the angle-angle similarity, and that says if you have two corresponding angles of a triangle that are congruent to two corresponding angles of another triangle, then the two triangles are similar. So if you remember from when we were proving triangles were congruent, anytime you have two angles in a triangle congruent to two angles in another triangle, we automatically know that the third angle is congruent. But that doesn't need to be said. That's kind of a understood postulate. So we don't need to mark that third angle, and we don't need to write angle-angle-angle similarity. We only write angle-angle similarity. So we are still going to have a similarity statement that's similar to a congruency statement. Well, actually, it's actually congruent to a congruency statement because a similarity statement matches up the corresponding angles by the order of the letters. So I can start anyway with my first three letters that I put down. Let's just say triangle PQR is how I want to start my similarity statement. Well, the order of the letters that I put here has to match exact angles P, Q, and R in the exact order of their corresponding matches. So P, angle P, we notice has one arc. It's congruent to angle T. So the first letter to the right here has to be angle T. Q has two arcs, so it must be in the same position as S, which also has two arcs. And then finally R has nothing here, but we know if we mark the third angle it would have three. So it's got to be in the same position as U in our similarity statement. Furthermore, when you're asked why these two triangles are similar, all you'll need to write is angle-angle similarity. You can abbreviate similarity by just writing this symbol here. This is a tilde. It means similar. The next way we can prove that triangles are similar is if all of their sides are proportionate. So if the measure of the corresponding sides of two triangles are proportionate, then we know that the triangles are similar. Remember, proportions are just setting ratios equal to each other. So we have to be careful when we set up our ratios. We have to match the corresponding sides. So what I do is in each triangle I label smallest side in triangle ABC, middle side in triangle ABC, largest side in triangle ABC. And I do the same thing in triangle DEF. 4 is the smallest, 5 is the middle, and EF is the largest. And that helps me when I set up my proportion. So what I'm going to do is I'm going to set up all my all my side lengths of triangle ABC over all my side lengths of triangle DEF. So I'm going to compare the bigger triangle to the smaller triangle, and first I'm going to compare small side to small side, so 8 to 4. Then I'm going to do medium to medium, 10 to 5, and then I'm going to compare large to large, 20 to 10. Remember, we want to reduce all of our ratios, so the way that these triangles are going to be similar is if all of their ratios are equal, so that means their sides are proportionate. 8 divided by 4 is 2 over 1, 10 over 5 is 2 over 1, and 20 over 10 is 2 over 1. So because these sides are all equal, that means that they are proportionate. So why are these triangles similar? We would write side, 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 similarity. And then to do our similarity statement, the first three letters here can go in any order. Let's just say A, B, C. But the next set of three letters has to be corresponding to the first set. So A to B to C goes medium to large. So the next set of letters has to go medium to large, D to E to F. Finally, we have the side angle side similarity. Remember, in similar triangles, the corresponding angles must be congruent. The sides are going to be proportionate. So if you have the measures of two corresponding sides of a triangle that are congruent to the measures of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. Remember, included means the angle formed by two given sides. So first, we check, are the included angles congruent? 47 is the same as 47, so we're good on that one. Then we need to write ratios comparing the side lengths. So you have to make sure you match up your side lengths accurately. 8 is the smallest side in this triangle, and 16 is the largest side. DEF, smallest side is 6 and largest side is 12. So when I set up my ratios, I'm going to compare triangle ABC to triangle DEF, and I'm first going to compare my small sides, 8 to 6, and then I'm going to compare my large sides, 16 and 12. Remember, we always want to reduce our ratios. 8 divided by 6, if you put in your calculator and hit math, enter, you're going to get a ratio of 4/3. And 16 divided by 12, well, the greatest common factor is 4, and 4 goes into 12 3 times. So we also have 4/3, or you can type in 16 divided by 12 and press math, enter. Because the ratios are equal, or they are proportionate, we can say that these two triangles are similar by the side angle side similarity. And then making our similarity statement, first three letters don't really matter, whatever order they're given in. I can just say A, B, C. But whatever is set up here at the first half of our similarity statement must match the second half of our similarity statement in the exact corresponding order. So A to B to C goes small side to large side. So I have to end my similarity statement with D to E to F, small side to large side, D, E, F. These are the only three reasons that we use to prove that triangles are similar. So when we're determining whether triangles can be proven similar, we're looking for the following reasons. We're looking for two angles in each triangle congruent. We're looking for two sides proportionate and the included angle congruent. And we're looking for all three sides proportionate. If we can find any three of those relationships, then we do have similar triangles. First one's really easy. We have one set and two sets of congruent triangles, or congruent angles. So we know that these are similar triangles by the angle-angle similarity. Our congruency statement is a little bit trickier, but if you're really careful and pay attention to detail, you're just matching the corresponding angles. A has one arc, so it's going to match up with D, so D goes first. B has two arcs, so it's going to match up with E, so E is second. And C has nothing on it, but if we mark the third angle congruent, it would match up with F in our congruency statement. Okay, number 2, I'm going to give you a hint. We're checking for the side angle side similarity. If we have the sides proportionate and the included angle, which we do, congruent, then we have similar triangles. So pause the video and see if you can set up the ratio of your sides, see if they are in fact equal, and then finish up the similarity statement if it's possible. And you should have gotten that these are not similar, because if we set up the ratio of the sides, let's see, this is the small side, this is the large side, this is the small side, this is the large side. So if I set up small 20 over small 18, that should equal large 36 over large 24. I type 20 divided by 18 in my calculator and I press math, enter, and I get 3/2. 36 divided by 24 in my calculator, press math, enter, and I get 10/9. Well, clearly 3/2 does not equal 10/9, so these triangles are not similar. That means that you will not have a similarity statement. Okay, I'd like for you to pause the video and try number 3. Obviously, you're given 3 sides in each triangle, so let's check the side-side-side similarity by setting up a ratio of all 3 sides and seeing if those ratios do in fact equal each other. So we compare the sides. First, I'm going to label small, medium, and large in each triangle so that I know which sides match with which. And then I'm going to make my measurements GHI on the top of my fraction and the measurements of SQR on the bottom. So small side is 24. Small side of triangle SQR is 15. We have to see if that equals medium 32 over medium 20 and see if that equals large 40 over large 25. When I reduce my ratios for 24 over 15, I get 8/5. 32 over 20, I get 8/5. And 40 over 25, I also get 8/5. So all the sides are proportionate. So that means that they are similar triangles by side, side, side. Now when I make my similarity statement, they already started us off with IGH. So we went small to medium. So in order to do small to medium in the second triangle, we have to do S, Q, R in that exact order. Alright, we're looking here. We have an included angle congruent in both triangles, so we're good on the included angle. Let's see if we can prove these similar by the side angle side similarity. So we're going to test our corresponding sides and see if the ratios are in fact equal. Pause the video and see what you get. Alright, you should have gotten SAS and triangle DJK similar to PZR. If you did not and aren't sure why, raise your hand or ask a friend. Okay, so now we're going to use similar triangles to set up proportions in order to find missing side lengths, and we'll call those side lengths, usually they'll be called side x, or denoted by a variable x. So the first thing we want to do is to figure out if we have similar triangles and to identify the similar triangles in order to find x. So the first thing I noticed is that this 26 here is the same as this 26 here. This one here, this HI is the same as WU, so this is 13. So if we draw these triangles separately, we have the triangle with the 2 hash marks, and then we have the bigger triangle. We have the bigger triangle that's marked with 2 hash marks and 1 hash mark. Now, it's important that you understand that the side length of this triangle here, GUI, is not just 13. It's the whole length, 26 and 13. So it's 26 plus 13 that makes up this side, and 26 plus 13 that makes up this side. So 26 and 13 is 39 for this side and 39 for this side. Well, we know we have our included angles are congruent because they're completely shared in both triangles. And our sides are definitely going to be proportionate because we have 26 over 39 equal to 26 over 39. And clearly 26 over 39 will equal 26 over 39 in both ratios. So we have the side angle side similarity, and then our congruent or similarity statement says GHW. So G to H to W is going to be similar to G to I to U. Now, in order to find X, well, the ratios of our sides is 26 to 39. We also have a third set of sides here. So if we set up a proportion representing this third set of sides, we know the ratio of the third set of sides has to be 26 to 39 equal as well. So the ratio 26 to 39 has to equal the ratio of 20 over x. And this is where your cross multiplication is going to come in. 26 times x is 26x, and 39 times 20 is 780. So we're going to divide both sides by 780. I'm sorry, yeah, nope, 26. Divide both sides by 26. So we're going to get x equals 780 divided by 26, or x equals 30. Okay, number 6.